So in question 4, plus q, q plus q. For this plus q to be in equilibrium, there will be two forces on the third chart. One will be one will be over here, F31. Okay, equilibrium mane ek bijo force opposite jose ne. Is that clear? So that should come from number 2. Got it? So magnitude wise F32 and F31 are equal. But that means small q is attracting plus q. Yes or no? Yes or no? That means small q has to be a negative.
Small q to find
small q to find small q. We have to find what is small q. બરાબર પણ એના માટે કદ હોય છે. See, small q will always be in equilibrium. Is that clear? The only question is plus q in equilibrium or not? It makes sense. So that the system is in equilibrium. System means everything should be in equilibrium. That is only possible if plus q is in equilibrium. Okay? Okay or not okay? આ તો equilibrium માં છે એનું ટેન્શન ન લો. આનું ટેન્શન લો. So F32 is equal to F31. Clear?
Yes.
So in magnitude, so that would be q into q upon distance d squared and 4 is equal to q into q upon d squared. Clear? Okay, small q will be equal to q by 4. But this is only magnitude. Attraction is a repulsion and an attraction. Yes or no?
Yes.
So that's why it's necessary that with sign q is equal to minus q by 4. Got it? Okay? So, પછી 5. Okay. So you see, it's given that there are 2 point charges with some charge given 126 microcoulomb and so on, and they are at distance 8 cm from each other. The string you can see is very long. It is 1 meter long, and half divided only 4 centimeters on one side. Is that okay?
Yes.
Okay or not?
Yes.
So suppose this angle is theta. Suppose the angle is theta. Right now we will get relations about the tension આવે તો tension ના component આવે. Is that okay?
Yes.
So E sin theta and T cos theta and so on so forth. So we'll have T sin theta is equal to mg and T cos theta. Oh sorry. T cos theta is equal to mg and ઊંધું લખ્યું ને T cos theta T sin theta. So T cos theta is mg and T sin theta is equal to Fe. Somebody Fe, that is what? Coulombian repulsion. Okay, there will be repulsion between these two. Force and repulsion. Yes or no? Okay. Divide करो. So tan theta is equal to Fe upon m. Okay. Okay or not okay? Now we have to finally find out the distance. That is when charge becomes half on one of them. When charge becomes half on one of them, we have to find the new distance between them. Okay. So પહેલા છે ને આ બધું થોડું સિમ્પ્લિફાઈ કરી નાખીએ. So tan theta. Okay, for small angle. This is a small angle. Look at it. Theta is here 4 centimeters and here 1 meter. So it's a small angle. Do you understand what I'm saying? Yes. Because 4 centimeters is very small compared to 1 meter. Clear? So for small angle, tan theta and sin theta લખું તો ચાલશે. Got it? Got it or not?
Yes.
And every is લખાય Q1, Q2 by distance suppose x square. Okay, and mg is constant. बराबर? Okay or not? Sure? Instead of tan theta I am writing sin theta because I am saying that this angle will be smaller. Now, sin theta is further equal to 4 અત્યારે છે, but when the charge will change, the distance will not be 4. Clear?
Yes.
So it will be x by 2. So it's pretty upon 1. Opposite. The new triangle will be like this. When the distance is not 8 anymore, it is x. We want to find x. Clear? Okay, this is the old case. This is the Newton. Fine. Is equal to k q1 q2 by x square ft. So ultimately we get that q1 q2 is proportional to x cube. Yes or no?
Yes.
Yes or no? q1 q2 is proportional to x cube. એટલે multiplication charge નું half થઈ ગયું ને. So x cube is a half થઈ જશે. So x cube will become 8 cubed by 2. Got there?
Yes.
Or not clear? For your knowledge, product of charges on this and on this is proportional to x cube. So earlier that distance was how much? 8. Okay, now if we make one charge half, so our multiplication half થઈ જાય. So that means x cube should also be half of earlier એટલે શું? Half of 8 cube, right? Because earlier the distance was 8. Clear or not? The x cube equal to 8 cube by 2. So that is 8 cube to that 5 to 9. It's divided by 2. So that is 256. So x cube 256. Right? Then now we have to decide which one would it be. So 5 hoy to 5 cube to 125. 6 cube 216. 7 cube 345. It will be somewhere between 6 and 7. Clear? Should be little bit more than 6 actually. Should be little bit more than 6. Clear? Okay?
Yes.
Exact 6 not. Okay, then 11. अच्छा रिंग નું ડેરિવેશન કર્યું હતું ને આપણે શું કર્યું અને મેક્સિમમ ક્યાં હોય
R by root 2.
હા and r by root 2 question છે એટલે you have to find where is the electric field maximum radius આપ્યું છે ને question okay r by
So 7th answer 4.
7 માં answer 2 है gravity નથી 7 line वाला क्वेश्चन तो नहीं था 18 वाला પછી ફ્લક્સ માં પોટેન્શિયલ નો ભૂલથી આવી ગયો હા એ છોડી દેજો વાંધો ફ્લક્સ માં ભૂલથી પોટેન્શિયલ નો ક્વેશ્ચન છે ઓકે લાસ્ટ ટાઈમ શોર્ટ કર્યા હતા ને ત્યારે આ બરાબર થયું નથી પછી બીજું કઈ 19 અને 21 માં આન્સર છે 19 ને 20 19 માં આન્સર 0 21 uniform electric field is there in 19 or in 21. Suppose 21 karo. In 21st from the side. Electric field lines will come in and go out. Yes or no? Yes. Whatever number of field lines will come in, the same number will go out. Okay? In fact, if there is uniform field and there is a surface of any shape, closed surface of any shape, the flux will always be 0. Right? 19 માં છે ને આ માઈનસ q ને એવું કઈ છે નહીં. it is a mistake. એ બીજા ક્વેશ્ચન નો ડાયાગ્રામ નજીક હતો ને એટલે ઈ એમાં ભૂલથી કોપી જ્યારે કર્યું હોય ને ત્યારે એમાં આવ્યું. ઓકે so minus q is not there in 19. Anything else? Fine. 3-2 તે ક્યાં પહોંચી ગઈ તું હજી તો ક્યાં શીખવાડ્યું છે 32 તો તને આવડે છે ફોર્મ્યુલા ચાલો તને પૂછું તને ફોર્મ્યુલા આવડે તો કરાવ્યો સ્ફેરિકલ કંડક્ટિંગ શેલ પોટેન્શિયલ ઓફ અ શેલ આવડે છે હા એમ તો હું તો ગમે તે પૂછી દઉં ચાલો 37 નો આન્સર શું આવશે એવું કમ ઓન What did we study in the morning? Electrostatics of conductors. Yeah, okay. So we are discussing the point, right? What was the last point? Each point in the body of the conductor. Is that same? Somewhere it is why we get, because electric field is zero everywhere, so the main potential difference find for also zero.
But एक point surface ऊपर हो यानी एक अंदर है तो बेन potential कोई भी same नहीं.
Every point in the body has same potential as the surface.
Surface ऊपर है तो बाहर की electric field ना ऊपर की पास आती है तो
ना. Not that. For a point on the surface, the electric field will definitely be normal. So what happens is that electric field actually doesn't start right at the surface. હવે આ થોડું વધારે ડિટેલમાં જાઓ તમારી બુકમાં કે તમારા લેવલ પર એનું એવું કંઈ હોતું નથી. Right? It is that electric field really does not start right at the surface. Okay. If you try to look at it microscopically, it will actually start a few angstroms from outside the surface. Electric field will start a few angstroms outside the surface. એટલે કારણ કે charge exactly surface પર. Is that okay? And but size of the atom is about an angstrom. What is it? Or half an angstrom. Whatever, approximately that. So it starts from there. Any on the no. What if? So the way you are saying કે અહીંયા ઇલેક્ટ્રિક ફિલ્ડ નહીં હોય, અહીંયા હશે સરફેસ સુધી હોય, but આપણે તો આ બાજુ જવાનું. So there it's not. You understood that electric field will not be at all inside the surface. यहाँ સુધી જો અહીંયા field line પૂરી થઈ. Do you all understand? The field line will come and end at the surface. ઓલી બાજુ નહીં. Right? That's why if you go from here to there, the potential difference will be zero. Okay. તમને યાદ કરો. Do you remember in first chapter we have derived the electric potential due to shell, electric field due to shell? એનો ગ્રાફ યાદ છે કેવો? Zero inside it. અને પછી અહીંથી આમ અચાનક ચાલુ છે. So think about it that way. Half point surface पर there is electric field. But the moment you move even one step towards left side, zero. Did you understand?
Yes.
Okay. And in this case, we are coming from surface to here. Alright. So although electric field is at this point, but the moment there is displacement, so the electric field has nothing. That's why the dot product will be zero. Okay. Yes. If you move only on the surface, then also dot product will be zero because normal, the electric field is normal. Yeah, this is an equipotential surface. Right? Well. Okay. So after having done this, 5, let's go to number 6. Can charge no na thate technically that surface conductor is normal. Excess charge cannot be in the body of conductor. That is on the outside. Each point in the body of the conductor is active. Electric field in a charge-free cavity inside of conductor is zero. So in other words, you can say outside or electric field from charges outside do not affect the cavity. Electric field from charges outside do not affect the cavity. Right. So there are some words that we need to understand. First of all, what's a cavity? See, suppose this is some randomly shaped body. Okay, on any other hole, this is a hole. Did you understand? Yes or no? Suppose this is some randomly shaped cavity that is a hole. See, it's in 3D. Please remember that. Okay, 3D in the sense a body. Suppose any hole in it. But they drilling for a hole so then that hole will remain inside. Yes or no? That is what is called a cavity. You can put objects in a cavity. Did you understand? You can put objects in a cavity. Right? Okay. So suppose this is a conductor. Okay, and this part is the body of the conductor. This part is the body of the conductor. And we are talking about a charge-free cavity. That is, there is no charge anywhere in this cavity. Right? Then, even if this conductor itself has a charge, okay, or even if you create some electric field and put this whole thing in an electric field, there will be no electric field here. Our region no electric field is there. Okay, that is what this sentence is telling. That is, even if there is electric field on outside, okay, even if there is electric field on outside, or even if there is charge on this conductor, then also, as long as there is no charge in this cavity, there will be no electric field inside the cavity. That is, at all the points in the cavity, in this hole, everywhere, the electric field will be zero if there is no charge here. Okay, that is what the statement says. Now, why it is like that? I like it. Okay, below to look it. Okay, let's try to think of reason. First of all, this is a charge-free cavity. That means there are no charges anywhere here. Second, this is body of conductor, so there are no charges anywhere over there. Yes or no? Yes. Okay. Sure. So, if you remember earlier how the electric field in the body of conductor is zero, what would happen is suppose you place this in an electric field, then electrons will start gathering over here because electric field is like this. Is that okay? And positive charge will start gathering over here. Make sense? Yes. Okay. Finally, everything will settle in equilibrium. So when it will settle in equilibrium, what will happen is just like electric field here will be zero. Why? Because of the two opposite electric fields. Same reason applicable here also, that over here there will be two fields. Which two? One is the induced field created by these charges coming here. Do you understand why charges will come here? Because electrons will get attracted opposite to the field. So they will settle here. That will leave a positive charge on that. So positive, positive, negative, negative here. So that will create electric field towards that. But there is obviously some electric field from outside. So that will be in the opposite side. Is that clear? Like that, the field in the cavity will become zero. Is that fine? Okay. Now, another way to explain this. There is no charge anywhere. So if you start taking Gaussian surfaces here and there and here and there, okay, because there is no charge anywhere at all, for all of them the flux should be zero. Is that okay? Now that means there is only one possibility. I mean two possibilities. Either electric field is not there, electric field no, the flux no, is that okay? Or the field is uniform. That's it. For a uniform field, whatever shape of Gaussian surface, what should we have? The flux will be zero. But then how can we decide whether it's not uniform? Right? We have possibilities either which two, either E is zero or E is uniform. Okay, then how do we decide that that second one is wrong and the first one is correct? Okay, let's talk about it. See, if the field was uniform, then definitely suppose let's assume that the field is towards the right side. Okay, and it is supposed to be uniform. Yes or no? બીજું તો કઈ પોસિબલ છે જ નહીં ને. Either it's uniform or it's zero. Now if it's uniform, let's say, then we have a problem. The field lines are starting from here. અહીંયા તો field line નથી. So they are starting from here. Yes or no? Yes or no everyone? Yes. Okay. તો અહીંયાથી start થાય તો અહીંયા શું હશે? Positive charge. Clear or not clear? Sure. Okay. And there will be negative charge here. Clear or not clear? Yes. But the problem is, like I've said, if you would consider it this way, then the external electric field, what is it doing? It's actually separating the charges on the two axes. Clear or not clear? The external field is separating the charges, one on left side and one on right side. So these positive charges will not remain over here. Is it fine? The positive charges will not remain over here. Where will they go instead? So they will go on that side. It is outgoing possible. Did you get that? It's not possible that positive charges line up on this side and negative charges line up on this side and we have uniform field, right? Because these negative charges will come here because of the external field. Got that? Okay. So what that means is, as long as the cavity is charge free, there is no charge anywhere inside, this would mean electric field is zero. So do you realize that this is like shielding or shield? Think of what is shield. First think of shield. Protect. Yes or no? It protects. So even if there is electric field outside, inside this there is no electric. We are going to strong electric field, no problem. As the moment charges become stationary, the electric field over here will become zero. Understood or not understood? So this whole idea is actually called electrostatic shielding. Okay, this is called electrostatic shielding. So you can say that a cavity inside a conductor is not affected by electric fields which are coming from outside. Is that okay? Cavity inside a conductor is not affected by electric fields that come from outside. Make sense? Okay, that's why it's called shielding. So whatever you put here, suppose you have got some sensitive instrument, for example electronics, right? Some electronic pieces are very sensitive, right? So if you put such electronic devices or electronic chips and all that here, then the electric field from outside will not affect over here. So this will remain safe. Did you get there? Okay or not okay? Yes. Right? But yes, again, safe only from electrostatic field, that is when charges do not move. Right? Typically that happens, you know how, that sometimes when you sit somewhere and don't move for a while and then you try to stand up, then your clothes will get that charge from where you are sitting, from the furniture, maybe plastic chair or something like that. Right? I'm sure you would have noticed that. Or not? It's current like it. Okay, you look at the start. Okay, so basically what happens is that when we sit somewhere, we stand up and we move, and suppose we want to touch or we want to do something with this electronic device, then you may not touch it directly, because if you touch, there will be some charge in your body. It will damage the capacitors and other parts of the circuit, right? Okay, so overall what is required is that if you want to protect it from outside effects while you are not using it, okay, then we want to keep it inside such metal cases. The moment you keep it inside metal case, it will not get any effect from such electric fields, small and big electric fields that come from. In fact, this is good enough to even protect from lightning. It is good enough to even protect from lightning. That is, if there is, let's say, a cage made up of metal. You get what I'm saying? Okay, and a person stands inside it, and lightning will strike on that case, nothing will happen to that person. Right? Nothing will happen to that person. Nothing is special about this case. Even in a metal box, the same thing would happen. Right? The main idea is this, that this behaves like a shield, a conductor, and the person is in the cavity, is inside. Is that okay? So electric field will not come inside. However strong the electric field is on the outside. Over here the electric field will not come. Clear? Right? Fine. Understood this one? But like I said, the main thing here, charge free is necessary. What happens if there are charges? That's what we are going to talk about very soon. Fine. The ladies this point. Can you repeat your question? You are saying that suppose there is cavity and there is excess charge. Okay. Then where will the excess charge go? Good question. Suppose you give this conductor some charge, electric field, or irrespective of that. Suppose this conductor is charged, but conductor has a cavity. Then where will the excess charge remain? Will it remain on inner surface or will it remain on outer surface? Okay. Let's try to analyze that situation. Okay, so it was a little detour. So here is cavity. Now, let's assume both of these. Consider charges remain and there is no charge here in the cavity. Okay, again this is a charge free cavity. And let's say we have given positive charge to this conductor. Do you think this will happen, or do you think this will happen? Which one do you think is more possible? The outer one. Is that okay or not okay? Actually, even here it's not. There's a slight drawing mistake. Charges will be here on this side. I mean, they are not inside the body. They are at this surface, at the surface. Is that clear? Yeah. So they will be on the outer. Why? That way there will be less repulsion. Is that clear? If they are on the inner one, they will repel each other and they may go away. But all this is once again only due to charge-free cavity. The moment there is charge in the cavity, the game will change. Clear? Okay, everyone understood the question and the answer is where? I made you write that charge will be on the surface, not in the body. Then Phalak is asking on which surface? On the inner surface or the outer surface? So if there is nothing in the cavity, then it will be on the outer surface. Is that fine? Okay. So this was which number? 6. Number 7. In a charge-free cavity, each point has same potential. Did you understand this? The proof करूँ. In a charge-free cavity, each point has same potential. Why? Electric field is 0. If electric field is 0, the potential will be same everywhere. Okay? Right? We can prove it by the delta V or Vp minus Va kind of formula. Okay? The left side here will be completely, right side here will be 0. So you get Vb equal to V for any 2 points in the cavity. Clear? Okay? In fact, you can extend that also to the surface. I hope you realize what. Suppose this is the cavity, okay, and here is the outer surface, and there is no charge in this cavity. Then this point A and this point B will be at same potential. Do you agree? Do you agree or not? Yes. Because there is no electric field anywhere here. Got it? Yes. But then B and S, they are also at the same potential. Using the point that we have learned earlier, that every point in the body of the conductor is at same potential, okay, as the surface. Clear? So everywhere here the potential is same. Fine? Sure? That's clear? Okay. ઉપર a એમાં લખો તો લખી નાખો as the surface. Equipotential object. This is not an object. Hold on. This is a hole here, right? You wouldn't call it an okay, right? This is vacuum here. Well, now the next, what happens if you put a charge? So, for a charge placed inside a cavity in a conductor, for a charge placed inside a cavity in a conductor, the electric field line for electric field is limited to the cavity. What does that mean? આ diagram માં use કરું ચાલશે ને? So suppose this is the cavity and here we put a positive charge. So this positive, assuming this is neutral, right? Okay, not necessary that it is neutral. Idea will be same. Assuming this is neutral, if there is a positive charge here, electric field line will try to go out in all directions. Is that okay or not okay?
Yes.
But in the body of the conductor, the electric field should always be zero in electron. Yes or no? So field line in your fully concealed. Did you understand?
Yes.
Now, if field lines end at some point, then there has to be some charge over there. Which charge?
Negative.
Negative charge. Is that okay? Do you remember field lines can only end at infinity or at negative charge? That means what is happening? It is very simple to understand. This positive charge, you put it here. So what will it do? It will start attracting the electrons from the body of conductor. Okay? And the electrons will come and they will settle on this surface. Did you get that?
Yes.
Yes or no? Sure?
Yes.
So if overall the body is neutral, suppose if overall the body is neutral and this inner surface gets minus q charge, if suppose overall the body is neutral, okay, and this inner surface gets minus q charge, then the outer surface will get plus q charge, that is the positive charges will come here. Did you understand?
Yes.
Okay, then what would happen next? Its own electric field will be created like. Did you understand the field line diagram? With yes, electric field normal at every point. Don't forget that. Over here also. Over here also the electric field has to be normal at every point. Did you understand the diagram?
Yes.
Sure. So electric field lines are discontinuous. Did you see that? અહીંયા છે, અહીંયા નથી, પાછું આગળથી ચાલો. Okay or not okay? Right? So for charge placed in a cavity, the conductor, the electric field is limited to the cavity, and આનું electric field ઓછું છે. Is that fine? But then because of attracting charges, there will be charges on the outer surface, and that's why the electric field will be there outside. Possible. Here we have drawn this diagram for a neutral conductor. Okay. Is it fine? Well, let's understand the next.
So, our external electric field also.
By external electric field હોય તો શું થાય? There will be two effects. One due to the inner and one due to the outer. Okay. So suppose આ બાજુ external electric field હશે. So that electric field will try to push some of the positive charges on that side. એટલે કેવું થશે? આ negative charge થોડો અહીંયા On the other hand, to compensate, there will be even more positive charge on this side. Is that clear? Is that clear or not clear? But yes, this conductor, if it is neutral, it will definitely remain neutral. And some negative charge will be here. Make sense? And on this side, there will be little less negative charge. It is called rearrangement. You get what I am saying? There will be a little bit of rearrangement. Okay, but the basic idea will still remain the same. It's like a combination of both of them. Got it? Yeah, but this electric field will never come here. It will never cross the body. The bar no under no jai, under the bar no. Is that clear? Because there is a metal body or conductor body. Right. Now, if charge plus આ બધી properties book માં નથી આપી. Okay, wait friend. In the book some 5 or 6 are only given. What I am doing is I am dividing them up in simple sentences so we can use it very easily in numerator. Okay, whenever required. If charge plus Q is placed in cavity in a conductor, the inner surface of conductor will have charge minus fix हो जाए opposite हो जाए गम्मे ते स्टेप पॉइंट let's prove. Suppose this is plus Q and this is some randomly shaped conductor body, okay, with this cavity, okay. And go में जाऊँगा ये वचन. So this sentence is telling you that in this case there will be inner, there will be minus Q total charge on this inner surface. अब plus Q है तो minus Q है. यहाँ minus Q है तो plus Q है. इधर okay, यहाँ plus no रखो तो एक case में चलता. If it's Q, it is minus Q. If Q is negative, automatically that will be positive. अच्छा वो क्या बताए? Easy to see. If we take a Gaussian surface, that is imaginary surface, that is very very close to this inner surface, okay, very close, infinitely or infinitesimally close. Did you understand what I am saying? Yes or no? Yes. Pure. This is the Gaussian. But this Gaussian surface, every point of this Gaussian surface is in the body, correct or not? Body of conductor. Clear? A body क्या है? A cavity, a body, right? So what's the electric field at every point of this Gaussian surface? Q by 0. नहीं, आगे property वाचो. Electric field at every point in the body of conductor. What's the electric field in the body of conductor? 0. Clear or not? Sure? Everyone got that? Baku ne? The other point for electric field 0. So total flux for this Gaussian surface 0. Why 0? Because electric field is 0 at every point over here. Fine? Fine or not? That means total charge enclosed should be 0. Are those 0 है ने? Gauss law says that phi is equal to sigma q enclosed. So total charge enclosed is 0. अच्छा तो यहाँ तो plus q देखा है चलो दाने minus q क्या? अब बाकी ना तो बोलो खाली है, right? Only matter can possess charge. So where is the other charge? It will be यहाँ से यहाँ होए तो हम आवे. Do you understand what I am saying? Enclosed. We are talking about enclosed. Where would it be? It would be on this surface. Clear or not clear? So here are negative, 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 negative. Is that clear? So total charge on this inner surface will be minus q. Why exactly minus q? Plus q. Total should be 0. Yes or no? Sure. So the next step I am writing it here. So we have plus q. And then charge on the inner surface, addition of them will be 0. So charge on the inner surface is minus q. Got it? Okay. ખબર પડી ને પ્રૂફ કે ન ખબર પડી? ફાઇન. Probably the last one. Now. Total charge within the outer surface, or if you want you can write, never mind, enclosed. Total charge enclosed by outer surface of conductor is same as total charge held by the outer surface. Okay, sorry, I just look at it. Charge. No. Never. There is no need of cut off. Then there is no need of it. Okay. Let's leave it to 9 more. Fine. Now let's try to use these things, okay, in some simple questions. First of all, suppose this is a conductor, okay, and with a cavity, right? If charge on the conductor, it is important to understand the meaning of these words. If the charge on the conductor is 1, okay, what that means is this body, its atoms, these atoms of this body, together they have how much charge? 1 coulomb. Is that okay? Right? Excess charge of 1 coulomb is there. Right? Now if I say that a charged particle with charge 0.1 coulomb is placed inside the cavity, find the charges on inner and outer surface of conductor. The simple question. Let's take some now. Use the concept that we have just learned. Done. Yes, Dhruv.
Inside minus 0.1.
Inside on the inner surface it will be minus 0.1. Clear or not, everyone? Sit down.
Outer surface.
And outer
0.1.
outer also 0.1.
Yes.
On the outer surface 1.1. 1.1. No, not 1.1. No, but
0.9.
0.9. Interesting. Sit down. Nothing बराबर एकदम perfect નથી સમજાવવાનું. Have a look here. This particular body, a body આને કહેવાય, આની વાળું body has how much charge? 1 coulomb. Is that okay? So total charge on this should be 1 coulomb. This is fine. First of all, this 1 coulomb should either be on inner surface or on outer surface. वच्चे तो क्या नहीं होगा. Is that okay? However you make 1 coulomb, it should be on inner surface and outer surface. Now, if given that means we are putting one positive charge here, how much? 0.1 coulomb. Clear or not? Yes or no? If we do that, what will happen? What will happen? There will be minus charge, negative charge on this surface. Yes or no?
Yes.
Clear? How much negative charge? Minus 0. So basically, if I just draw the conductor again, on this inner surface, QIN is minus 0.1. Clear? Clear or not? And the total charge that this whole body has, again, is how much? 1 coulomb. એને તો કોઈ ટચ કર્યું નથી, એનો ચાર્જ તો ક્યાંય નહીં જાય. Is that clear? So even if this is minus 0.1 coulomb, total charge should still be 1 coulomb. So then how much charge should be there on the outer surface? 1 coulomb. 1 coulomb હોય તો total 1 coulomb કેવી રીતે થાય? તો 0 હોય તો total 1 coulomb કેવી રીતે થાય?
Plus 1.1.
1.1. Is that clear or not clear?
Yes.
Clear or not clear?
Yes.
Very well. This is not called charge on the body. First of all, is that okay? This is the most common point of confusion. આને ગણવાનો જ નથી 1 coulomb. Is that clear or not clear? This is charge particle which is here. It is not the body. Fine. Okay. So now, very simple. We don't know how much charge is in this context. We know charge is either on inner or on outer surface. Okay. So total charge is 1 coulomb on the body. Correct or not? So 1 coulomb should be equal to QIN plus X. Yes or no?
Yes.
Do we know QIN on the inner surface? How much? Minus 0.1. So put it there. So 1 equal to minus 0.1 plus X. So how much is it? 1.1. Got it or not?
Yes.
Yes or no?
Yes.
તમને આજ લખાવા જતો હતો, પછી મને એમ કે એમાં કંઈ લખાવાની જરૂર નથી, તો આવી રીતે કરીએ તો થઈ જાય. Right? Is this clear?
Yes.
Okay. Okay. Everything clear so far? Shall I erase this? Simple question. Suppose there is a plus Q charge at this point. Around that, we have a spherical conductor which is hollow. This is a spherical conductor. Iron center. It's called hollow spherical conductor. Is that okay? This is a hollow spherical conductor. देखाई दे with inner radius r, outer radius 2r. Did you get that? Inner radius r, outer radius 2r. Fine. Fine or not? Yes. Your question is as follows: draw graph of electric field versus distance from center. Draw graph of electric field versus distance from center. Conductor is neutral. Generally, kind of kiddo hai the vastu neutral. Okay, nothing about conductor is mentioned. પહેલા તો અહીંયા પ્લસ ચાર્જ મૂકો એટલે શું થાય? There will be electric field. પહેલા ચાર્જીસ ક્યાં ક્યાં ઇન્ડ્યુસ થશે? બીજે ક્યાં આવશે ચાર્જ? ક્યાં આવશે?
Inner surface.
અને inner surface. How much charge? એટલે અહીંયા બધે આવશે minus q. એટલે total minus q. Is that okay?
Yes.
અને surface 1 કહ્યું. So q1 is equal to minus q. That's what you all are saying. Is that okay or not okay?
Yes.
બતા દો. હવે outer surface પર કઈ આવશે?
Plus
q2. q2 equal to plus q. Got it?
Yes.
Got it or not? Sure. Okay, so there is some positive charge distributed and symmetry છે એટલે બધું symmetric જ આવશે. Got it? Okay, everywhere everything is symmetric. Now we have to draw graph of electric field Fine. Let's leave this question here. Okay. You try to think about it. इन टापो जो अलग-अलग पॉइंट लो, एक पॉइंट અહીંયા લો, ત્યાં ફોર્મ્યુલા બને છે ઇલેક્ટ્રિક ફિલ્ડની, એક પॉइंट અહીંયા લો, અહીંયા તો શું આવશે? 0 જ આવે ને, એમાં કે વિચારવાનું નથી ને. ધારો કે પછી એક પॉइंट અહીંયા લો. ત્રણ પॉइंट લઈને ઇલેક્ટ્રિક ફિલ્ડની શું ફોર્મ્યુલા આવે? That belongs to first chapter, doesn't it? In reality, we are using properties of conductor, but the remaining things are from first. Okay, shell well, याद છે ને બધું? Electric field of a shell. આ shell જ કહેવાય કે ન કહેવાય? Charge is only on this sphere, shell. Similarly, charge is only on this shell. Yes or no? એટલે કે તે કરીને find કરી. Got it? No. No. Are you sure about that horizontal? I mean, જેટલું પૂરું થાય અહીંયાથી જ ચાલુ થશે? Are you sure? We'll see. Tell this.